This is section 5.2. After the video, sum and difference formulas. Sum and difference formulas for cosine and sine. The cosine of alpha plus beta is cosine cosine minus sine sine. So that's the pattern. And notice that for cosine, if it's a plus here, it's a minus in the formula. So cosine, you want the opposite sign. And with sine, the pattern is sine cosine cosine sine. And notice that it's the same sign, plus here and a plus here. So sine is same sign. Checkpoint 1, we know that cosine of 30 degrees is square root of 3 over 2. Obtain this exact value using the fact that cosine of 30 is cosine of 90 minus 60, and the difference formula for cosines. The pattern for cosine is cosine of 90, cosine of 60, and cosine is the opposite sign. That's going to be plus sine of 90, sine of 60. Now we just write the values for all these. Cosine of 90 is 0. Cosine of 60 degrees is 1/2. And then we have the sine of 90 is 1 times the sine of 60 is square root of 3 over 2. And we have 0 plus square root of 3 over 2, which is square root of 3 over 2. Checkpoint 2, find the exact value of cosine of 70, cosine 40, sine of 70, sine of 40. This is the pattern for the cosine, angle addition for cosine. And but if it's a plus in the formula, it's going to be minus when we put it back together. So we're kind of doing this formula backwards. That's the cosine of 30 degrees, and the cosine of 30 degrees is square root of 3 over 2. Checkpoint 3, verify this identity. Well, let's make the left side look like the right side. Cosine of alpha, cosine of beta. We're using the pattern for cosine. Cosine, we need the opposite sign, so that's plus sine of alpha, sine of beta, and that's over this denominator, cosine of alpha, cosine of beta. Well, our next step is, let's go with common denominator. Cosine of alpha, cosine of beta over cosine of alpha, cosine of beta, plus sine of alpha, sine of beta over cosine of alpha, cosine of beta. Now these are exactly the same. Both of these cancel out, so that's where we're going to get the 1 plus, and then sine of alpha over cosine of alpha is tangent of alpha, and sine of beta over cosine of beta is tangent of beta. Find the exact value of sine of 5 pi over 12 using the fact that 5 pi over 12 is pi over 6 plus pi over 4, which is, really if we have 2 pi over 12 plus, and if we multiply the top and bottom by 3, it's 3 pi over 12. So that's where they're getting the 5 pi over 12. Find the exact value of the sine. So we want the sine of pi over 6 plus pi over 4, which is really sine of 5 pi over 12, is equal to sine of pi over 6 cosine of pi over 4, and we're using the pattern for angle addition for sine. Sine is the same signs. That's going to be plus cosine of pi over 6 and sine of pi over 4. Now the sine of pi over 6 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Plus the cosine of pi over 6 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. On top here we have square root of 2 over 4. Here we have plus square root of 6 over 4. So that's all over 4. Checkpoint 5. Suppose that sine of alpha equals 4/5 for a quadrant 2 angle alpha, and sine of beta is 1/2 for a quadrant 1 angle beta. Find the exact value of each of the following. Cosine of alpha. Well, alpha is a quadrant 2 angle, we're told. And we're also told that the sine of alpha is 4/5. So 4/5, this is -3. The cosine of alpha now is -3/5, adjacent over hypotenuse. Beta is a quadrant 1 angle, and we are told that the sine of beta is 1/2. So 1/2, and then this side, well, we know if sine of beta, if that's 1/2, then the cosine is square root of 3 over 2. But if we're saying, well, we need the x here, x squared plus 1 squared is 1 is equal to 2 squared, which is 4. So x squared is equal to 3, so x is square root of 3. Now the cosine is square root of 3 over 2. So cosine of beta is square root of 3 over 2. C, cosine of alpha plus beta. We'll just follow the pattern. We have cosine of alpha, cosine of beta. Cosine's the opposite sine, so we have sine of alpha, sine of beta. Well, cosine of alpha is -3/5. Cosine of beta is square root of 3 over 2. And we're going to go minus the sine of alpha is 4/5. That was given. And the sine of beta is 1/2. We end up with -3 square root of 3 minus 4 over, that's a 4, over 10. Sine of alpha plus beta. So we have sine of alpha, cosine of beta. Sine is the same sine, so we have plus cosine of alpha and sine of beta. So sine of alpha is 4/5. Cosine of beta is square root of 3 over 2. Plus the cosine of alpha is -3/5. And the sine of beta is 1/2. We have 4 square root of 3 minus 3 over 10 for an answer. Example 7, verify an identity. Verify that the tangent of x minus pi over 4 is this over here. You can tell I'm recording this at school, if you heard that bell. Tangent is, let's see, tangent, we want tangent of x, and then on top we have the same sign, which is tangent of pi over 4, and that's going to be over 1 minus, and then we have the tangent of x, actually this is going to be a plus, it's opposite side on the bottom, and then tangent of pi over 4. Now the tangent of pi over 4 is 1. On top we have the tangent of x minus 1, and then if the tangent of pi over 4 is 1, on the bottom we have 1 plus tangent of x, which is what we want, except this is backwards, but that's plus and it doesn't matter.